Your smartphone, your car's brakes, the hospital machine keeping someone alive, an artificial intelligence learning to think, none of them work without it. A chip smaller than your fingernail and the world is running out. Semiconductor memory is the brain's short-term memory. Today's world runs on three types of memory. DRAM, the fast, volatile scratchpad inside every computer. NAND flash, the persistent storage in your phone and SSD. And HBM, high bandwidth memory, the ultra-fast fuel powering AI supercomputers. Together, these three form the invisible nervous system of the digital economy. And all three are in short supply. Making a memory chip requires some of the rarest, most geographically concentrated materials on Earth. Silicon wafers, 60% sourced from Japan and Germany. Ultra-pure neon gas, 70% of global supply came from Ukraine until war tore everything apart. Gallium and germanium, China controls over 80% of the world's refined supply. And in 2023, Beijing restricted their export as a deliberate geopolitical weapon. This isn't a supply chain, it is a minefield. The shortage isn't just about supply, it is about an explosion of demand that no one was ready for. The COVID-19 pandemic sent a shockwave through chip supply chains that lasted years. Factories shut, shipping froze, cars sat unbuilt on assembly lines, hospitals waited for ventilators. Then came the age of generative AI, ChatGPT, image generators, self-driving cars. Every AI model runs on hundreds of thousands of memory chips. A single NVIDIA H100 GPU needs 80 gigabytes of HBM. 6 stacked memory chips per GPU, and the world can barely make enough. Building a new fabrication plant takes 3 to 5 years and costs $20 billion. The world simply cannot build fast enough. Governments across the world have declared semiconductors a matter of national security. The United States passed the CHIPS and Science Act in 2022, $52 billion in subsidies, with Intel, TSMC, and Samsung all announcing megafabs on American soil. The European Union launched the European Chips Act, 43 billion euros, with a goal to double its global chip share to 20% by 2030. Japan partnered with TSMC to build a massive new fabrication plant in Kumamoto, backed by billions in government subsidies. China launched its own $40 billion national chip fund, pushing its domestic companies forward despite American export restrictions blocking the most advanced chip-making equipment. India, home to 1.4 billion people and one of the world's largest electronics consumers, has historically imported nearly every chip it uses. That is changing. In 2021, the Indian government launched the India Semiconductor Mission with 76,000 crore rupees in incentives, with one clear goal: build chips at home. In 2023, Micron Technology broke ground in Gujarat, a $2.75 billion semiconductor assembly and testing facility, the first of its kind in India. Tata Electronics announced India's first silicon fabrication plant, an $11 billion facility in Dholera, Gujarat, in partnership with Taiwan's Powerchip. India's bet is to become the world's third great semiconductor hub, after East Asia and America. The nation that controls semiconductor memory will control artificial intelligence, medicine, warfare, and finance. We are living through the early years of a war fought not with armies, but with fabs, patents, and supply chains. The question is not whether chips will run the world, they already do. The question is who will make them.